Hello, welcome to the count vectorization video. We're going to use scikit-learn. It's under feature_extraction.text. Text itself is generally unstructured data. If you look at comments on Yelp or IMDb, or I've done natural language processing on reviews for like a mobile app, you can write your comments about that. Good thing to use with that, you can do sentiment analysis to see how strongly someone likes or dislikes something. You could do that on Yelp, IMDb, or wherever you want to get your text data set. But count vectorization is one of the more common methods. They now have newer ones. There's one called term frequency, inverse document frequency, and then there's the use of tensors using models such as PyTorch. That would be more of a deep learning model, and it requires a lot of setup, so we didn't do that. So we're going with the more basic count vectorization, and as it says, count vectorization involves counting the number of occurrences each word appears in a document, so it looks for words. So here we create our count vectorizer is the object we're creating. So we have our vectorizer. This is the text we're going to use. It's just the definition of count vectorization from the site that talks about it. Here I apply the count vectorizer to the sample text list up above here. And I can actually print out the tokens. So what it does is it tokenizes or breaks the words out into tokens. And you can see that right here. So here's the vocabulary. It gives it each word is broken. So this would be a word tokenizer. You can actually do a sentence tokenizer, paragraph, or even character tokenizer. So word tokenizers are the most common one. So here each word is broken out, is found, and it's given an index number. You'll notice it is alphabetical because accomplish has been set to index 0, but if you look, it's not the first word, right? So it goes alphabetically, indexes alphabetically, appears as a 3, somewhere in here is the 1 and 2. But it's alphabetical, it'd be an A. So there's also a concept called stop words. Generally, if you're going to do natural language processing, you would take this sample text and apply stop words to it, which is going to get rid of words like are, that, be, in, a, and, the. Those are common words that are going to occur a lot in text and don't add any value to it. So you get rid of those using stop words. They have them in various languages, so we would use such as the English stop words to do it, or the French or whatnot. So you can see it has tokenized, it has broken this sentence down into word tokens, and it has given them alphabetically, given them an index number. Here we're going to create a vector out of it. So we're going to transform the text using the vectorizer into a vector, and then we're going to print it here, and this is the final vector. So what it will do is give me the word counts based on the index. So this one is 0, 1, 2, 3, 4, 5, 6, 7. So at 7, it occurs twice. And B is at 7. So if I was to look, there's B, there's B. Those are the two occurrences. So yes, B has occurred twice. So you can see how quickly it was able to do a count and broke it into words, gave it an index, and it's able to turn that index into numbers based on occurrence. That's what the entire text data set would convert to. You can get a vector for individual words or more than one word. So in this instance, we're going to do the transform on just the word count, and we're going to see this was what would be called one-hot encoding. It's all ones and zeros. The 1 will show the position it's in, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think 11, index 11. If I can find it, would be, you've probably already found it, would be the word count. Here it is. And it is. Count is in the position 11, so it found it. One thing I'll note too is look at, like, there has a capital, count has a capital, but you'll notice when it tokenizes it, it levels the playing field to all lowercase. So a count with a capital C is the same as a count with a lowercase c. So it's smart enough also to lowercase everything. So you would it automatically lowercases and then apply stop words to get rid of those common words. And you can do it, but I can quickly tell if something is in the text. And you can add more than one word to search for. We know B's in there twice. So we could simply run through that. Let's get through our previous visualizations here. And we can quickly see what index. There's the word that, and there's first word. This is count. It's at index 11 right here. Here's the second word, and it is at the index 7 count. So it can do more than one, and it breaks it out into one hot encoded value, which makes it quick to find and look. So think of images and text or words get broken out into these one hot encoded vectors. And there's only one, and that's the position it sits at. So you can see how image classification, recognition, or text classification or recognition can be much faster by simply using vectors with ones and zeros. So that's what I wanted to show for count vectorization. Thank you.